Welcome back, Calculus. We're ready for 6.7, and we've already worked with average velocity. If I take it back, remember the average velocity, just think of it like a secant line of P of B minus P of A. If A and B are the endpoints, that is, divided by B minus A. And the same thing with average acceleration. That would be the derivative of velocity. So like the secant line of velocity over B minus A. So there's a reason why we're going back to this unit. Because if we were to look at this next statement, is this equal to something? Well, if we examine this statement a little bit closer, let's ignore that. Well, let's just rewrite 1 over B minus A real quick. The integral from A to B of A of t dt is equal to V of B minus V of A. Now, remember when we multiply fractions, that's the same as just multiplying straight across. So we're looking at V of B minus V of A over B minus A, which is equivalent to average acceleration. So when do you use which formula? Well, it depends. If you're given information about the acceleration and asked for average acceleration, then use this formula here. But if you're asked about average acceleration and you're given several velocities, then you're going to use this formula here. And I should have color coded this a little bit better, but I can say the same thing about average velocity. If you're given position graphs or a position table and ask for average velocity, then use this formula up here. Otherwise, you might have to use this formula down here, and all the work is the same because the integral from A to B of B of t dt is P of B minus P of A over B minus A, which is equivalent to average velocity. So just to make sure I'm not missing anything, just kind of going back. If you need to hit pause at any point, this is a little bit cleaner than the way I wrote it as well. So the average value of a function, f of x, on an interval is equal to this formula. So make sure you have this written down. But notice that an average value problem could be found a different way, dependent on the information that's given to you. So be ready for this type of problem. All right. So let's go ahead and talk about the very first example, I guess. Let me go ahead and write down that formula. 1 over B minus A times the integral from A to B of f of x dx. I know there's going to be more in the notes there. So anyway, if we're asked to find the average value of a function, and they only give you the function, not the derivative, they just give you the average value there, then what you have is 1 over the endpoints. I mean, this really is a slope problem. And then using a calculator, the integral from 1 to 3 of f of x dx. So from here, I would just go to a calculator. Now, I might do 1/2 in my head, but I think you know my clues for you right now. Always just go into y equals in case you need to use that formula multiple times. In this case, you only need it once. It's the square root of sine squared. I just like to make sure that I type things in correctly. It's weirdly written, but I don't want to make any conjectures right now. So anyway, I would, I wouldn't even bother doing 3 minus 1. I just know that that's 2. And then math, the ninth option from 1 to 3, and then alpha trace to grab that equation that we just typed in, and we double check that it was correct in terms of x. You get 5.848. There we go. So looking at the next one, it says it's a non-calculator, so let's power through without a calculator. We're practicing average value, so we're 1 over the bound, 6 minus 2, the integral from 2 to 6 of f of x, which at this point, because it's a non-calculator, I would actually write it out. So as I'm working through, I'm thinking 1/4 times the quantity, the antiderivative would be 2x, add 1 to your exponent, multiply by the reciprocal, or half of 4 is 2, from 2 to 6. I like to do that 1/4 at the end. That's my opinion. So 2 times 6 is 12. 6 squared is 36. Times 2 would make that 72. Minus 2 times 2 is 4. 2 squared is 4. Times that 2 would be 8. So what do we have? We have negative 60. I'll move over here. Minus negative 4. So 1/4 of negative 56, if I'm doing my math right, would give me negative 14. And we'll double check that that's right. There we go. So as we get into a little bit more complicated of things, so we have a snow machine shooting snow on a ski slope, and we have this equation. If the snow is added, it's pretty important that you pay attention to what's happening to the slope per hour. Is modeled by this. Notice that I'm reading this as a rate equation. It'd be nice if they actually gave me units here, but I don't see them. And then they say the rate at which the snow melts, so think about melting would be taking away, is modeled by this equation. Oh, here's the units. Units is cubic yards per hour. And they're only measured from 0 to 24 hours. At t equals 0, our slope holds 50 cubic yards of snow. So that's super important, maybe even important enough to highlight. Anyway, so what's the total volume of snow added to the mountain over the first 6 hours? Well, all that's saying over the first 6 hours is we don't care about what's melting, just what is added. So that would be the integral from 0 to 6 of s of t dt. I wouldn't even spend any time assuming that this is a calculator question, which it would be. So I would go to my calculator and start typing away into my y equals. While I'm at it, I also do both equations, x, and then with parentheses, so I need sine of x over 14. That quantity needs to be squared. Just double checking that I typed that in correctly. I'm pretty sure it's good. 24 minus x sine of, see, the x is not squared, it's only sine that's being squared, so I believe I typed that in correctly. And while I'm at it, I might as well have the other equation, 10 plus 8 cosine of x over 3. Just double check that you type that in. So y2 is the melting equation. There we go. So back in my home screen, I can just hit math for my ninth option from 0 to 6 and alpha trace to grab that equation. In terms of x, it looks like 142.413 cubic yards. Yards cubed. That's exactly what they got. So let's just talk about, because I don't know if I'm gonna. Oh, they want you to find the value of each of these. So what we could do is we could actually just type that into y2 into our equation, which I already did. So you have a couple of options. You can actually just grab that because it's the same thing, and then just change y1 to be y2. And what you could do as well is hit alpha trace to do 1, 6, and then go up and grab that equation. Or just take this 81.823 and divide by 6. So you have several options here. As I'm going to go back to the answer key instead of me writing it down. Notice that that was an average value problem for a rate. So this is average rate. So that's why when we did the integral, we took away a unit, but because this is a slope problem, it's almost like we took away a unit and put it back in. So I know it's confusing, and this is calculus, so don't be discouraged. Once you figure out these values, it makes sense then, and you understand how this is an average value problem, so it's got to be a rate. Average rate of change, it might be another way of saying that this unit makes sense. So let's read through this. The first answer represents the total volume of snow that has melted, whereas 1/6 of that represents the average value, so it's the average amount that is melting per hour from t equals 0 to t equals 6. So hopefully my explanation makes sense. I know it's confusing. Please write down any questions you may have. Okay. On the next part, is the volume of the snow increasing or decreasing at t equals 4? Okay, well, if we're increasing or decreasing, what we want to do is examine the rates a little bit. So what you can do is just say, well, at S of 4 minus M of 4, and you can easily do that with your calculator. Alpha trace for the first equation, 4. So that's the rate that's being added at t equals 4, minus alpha trace second equation at t equals 4. We get an answer of about 11.800. So at that exact moment, we have a positive answer. Well, if we have a positive answer, that means that the rate that's being added must be larger than the rate that's taken away. So we have an increasing at that moment, which makes perfect sense to me. And I think, to me, writing down this statement is a justification. I don't think the answer key actually has that question. Oh, they took it a step further and actually wrote out what the formula was and then took the derivative of each of them. I was going to wait to do the formula in part D. Anyway, you can see he got 11.8 though. Okay, let's talk about D. I'm going to try and race through this. I got another problem. Okay. If you notice in that formula, it talked about the starting, that at the beginning we had, I think it was 50 in the problem, wasn't it? We had 50 cubic yards of snow at the beginning. We're going to add to it the snow that was added from 0 to 5 of S of t. And then we have to take away, now you could rewrite that integral if you want, or you can just write minus m of t dt. And that's a property of integrals that we've learned. So if I go to my calculator, I can just type that in, 50 plus the math, the ninth option from 0 to 5, alpha trace y1 minus alpha trace y2 in terms of x. And you get your 95.335 cubic yards.